Now what I want to do, I want to show you guys, okay, how to use the standard reduction potential table to predict the activity of metals and whether or not a single replacement reaction is going to occur. Okay. Um, Let me explain what it means to be an active metal. Active metals are metals that are easily oxidized. An active metal is a metal who likes to lose electrons, likes to become the, metal cation, okay? Like likes to give away electrons. So metals that are easily oxidized are more are were called active metals. Metals that don't like to lose electrons, they are not active metals. They're the least active metals. So how can you use a table of standard reduction potentials to predict who is eager to lose electrons and who is not? Well, down here at the bottom, this is where your most active metals are going to be. Most active metals. The most active metals are at the bottom of a standard reduction potential table. Here's why. If you look at these reductions, these have negative voltages. These metals don't want to be reduced. They actually want to go in the other direction. They want to be oxidized. So lithium is the most active metal out of all metals, right? And that shouldn't surprise you. Okay, lithium very eager to lose electrons to give them away. Okay, it's not mad about it at all. This is why we have the lithium-ion batteries. Okay, we're not going to get into how lithium-ion batteries work because they're pretty complicated. Okay, but lithium is the metal of choice for batteries because nobody else is even close. I mean, I guess potassium, we could have a potassium battery. Okay, but lithium, is very eager to give away electrons and produces a high voltage when it does it. Yeah, the metals at the top of the standard reduction potential table, these are the ones that like to be reduced. And the metals at the top of the standard reduction potential table, these guys are the least active metals. They're the least active metals. And gold is, because the rest of these guys aren't really metals, right? Okay. Gold is like the last of the metals. Gold is the least active metal out of all of these. Nobody takes electrons from gold. Gold wants to gain electrons, it doesn't want to give them away. Okay. So gold is not giving away its electrons. So, if a metal is below another metal, the metal that is on the bottom is the most active, and the metal that's on the top is the least active. And you can use this to predict whether or not chemical reactions are going to occur. More active metals will give an electron to less active metals, but a less active metal is not going to give an electron to a more active metal. So let's look at one of the practice problems that we have on here. So if I put lithium solid, and this is actually the first part of the lab tomorrow is to develop an activity series. If I put lithium solid in a solution of magnesium cations, I want to know, is a reaction going to occur? Well, lithium's the metal here. So is lithium a more active metal than magnesium? If lithium's a more active metal than magnesium, it will absolutely give its electrons to magnesium, right? So if we go to the standard reduction potential table, we're looking to see where lithium is and where magnesium is. And the answer is, yeah, lithium is more active than magnesium. So lithium would give its electrons to magnesium and it would become magnesium cations and it would become magnesium. So this reaction will occur. If you put a solid piece of lithium in a solution of magnesium ions, that lithium will dissolve and you will start to see magnesium precipitate out or crash out of the solution. So that's a big old yes for this one. That is a big old yes. Yes. All right. I would like you to try this one. Will iron give electrons to calcium? Is iron a more active metal than calcium? Then it will give electrons to it. Or is it not going to give electrons? So I want you to take a look at that standard reduction potential table and try to predict whether or not that reaction is going to occur. All right, so here's calcium and here's iron. Iron is not going to give electrons to calcium. Calcium would give electrons to iron, but not the other way around. This one is a big ol' no. Hopefully you got a no for that one. All right, I would like you to try 3 and 4. Okay, will lead give electrons to silver? And will gold give electrons to acid or H+? plus? Go ahead, use your standard reduction potential table to try and predict those. All right, will lead give electrons to silver? The answer is, oh, yeah, let's find it. Okay, the first lead is right here. And the first silver is right here. So yeah, lead is more active than silver. It will give its electrons. The last one was gold and H plus, and that answer is a big old no. Gold all the way up here. Gold ain't giving electrons to nobody. H plus down here, not gonna happen. So that one is a big old no.